Life on Earth is incredibly tough, but it's not invincible. Over hundreds of millions of years, our planet has faced these moments of, well, profound crisis. Events so powerful they basically hit the reset button on evolution itself. We're talking about mass extinctions, the planet's deadliest events. And today, we're going to dig into the forces that caused them.
Okay, let's just start with a number. 84%. Yeah, just let that sink in for a second. What on earth could that possibly represent? Well, it's the casualty count from our planet's single most devastating catastrophe.
That's right. During an event 252 million years ago, an event nicknamed the Great Dying, 84% of all families of species in the oceans just vanished. It was the closest life has ever come to being completely snuffed out. And in doing that, it cleared the way for a brand new world, one that would eventually give rise to the dinosaurs.
So what exactly are we talking about when we say extinction event? Well, the official definition is a widespread and rapid decrease in Earth's biodiversity. But let's be clear, this isn't just a few species dying out, which, happens all the time. No, this is a sudden, catastrophic collapse of ecosystems on a totally global scale.
And believe me, this has happened before. It's not a one-time thing. While there have been lots of smaller extinction pulses, scientists have pinpointed 5 truly colossal events in the last half-billion years. We call them the Big Five, and they're really the major chapters in the story of life's struggle to survive. So what could possibly cause such devastation? Let's take a look at the culprits.
First up, we're going to look at threats that come from deep within the planet itself. The ground beneath our feet feels solid, but it's not always stable, and sometimes its inner fire boils over with world-ending consequences.
Now, we're not talking about a single volcano like Mount St. Helens, not even close. I want you to imagine giant cracks in the Earth's crust ripping open across an entire continent, just spewing lava, nonstop, for maybe a million years. These are called flood basalt events, and they can bury areas the size of Western Europe in molten rock. The destruction just cascades from there. First, the eruptions throw so much dust and gunk into the atmosphere that they block out the sun. Plants die, and then everything that eats the plant starves. Then you've got sulfur gases mixing with rain, creating acid that burns forests and turns the oceans toxic. In the grand finale, colossal amounts of CO2 trigger a runaway greenhouse effect, basically baking the planet for centuries. This exact scenario, this is the leading theory for what caused the Great Dying.
All right, so we've seen the dangers boiling up from below. Now, let's turn our gaze upwards, to the skies, and look at the threats lurking in the silence of space.
Okay, this is the one we all know, right? The Hollywood blockbuster scenario. A giant rock from space slams into the Earth. An asteroid or a comet just a few miles wide can release more energy than all the nuclear weapons on the planet combined. It's the ultimate disaster movie, a single horrifying day that changes the world forever. And the aftermath is just as brutal. A lot like the volcanoes, the impact kicks up a massive cloud of pulverized rock that wraps around the entire globe, blocking the sun and creating what's called an impact winter. The sheer force can trigger earthquakes, mega tsunamis, and ignite firestorms that sweep across continents. This is exactly what happened 66 million years ago, and it brought the 150 million year reign of the dinosaurs to a very abrupt end. And asteroids aren't the only thing to worry about out there. Imagine a nearby star exploding, a supernova, or a gamma ray burst. If one of those were close enough, it could blast our planet with so much radiation it would literally shred our protective ozone layer. And without that shield, the sun's UV rays would basically sterilize the surface. It's a much rarer threat for sure, but just as deadly. So we've got fire from below and rocks from above. But, some of the deadliest killers are actually way more subtle. Sometimes the world doesn't end with a bang, but with a slow, creeping change in the very air we breathe and the water we drink. Earth's climate is really a delicate balancing act. If you tip it too far in either direction, things just start to fall apart. A long period of global cooling, for instance, can lock up the world's water in giant ice sheets. Sea levels plummet, and lush areas turn to desert. On the flip side, rapid global warming can melt those ice caps, flood coastlines, and totally mess with ocean chemistry. Both paths can lead to a total collapse. So how does that collapse actually happen? Well, big changes in sea level can wipe out critical coastal habitats. Even worse, a warming ocean can lose its oxygen, creating these vast dead zones that suffocate marine life. These climate-driven disasters are the slow-motion killers of the extinction world, and they've been linked to several of the Big Five. Okay, so let's do a quick recap. We've basically got three main natural culprits for mass extinction. You've got cataclysms from below, like those giant volcanoes. You've got strikes from above, like asteroid impacts. And you've got these insidious changes from within our own climate system. Three different paths, all leading to the same devastating end.
For 4.5 billion years, these have been the primary ways a world could end. But in just the last few centuries, a new force has emerged on the scene, a force that's changing the planet at a speed that rivals these ancient cataclysms.
The thing is, many scientists are now saying that we are living through the planet's sixth mass extinction. But this one is fundamentally different. There's no asteroid hurtling towards us, no continent-sized volcano erupting. For the first time in Earth's history, the cause is a single species, us. The term they're using is biological annihilation.
So what does that actually mean? Well, it comes down to this number, 1,000 times. That's how much faster species are disappearing today compared to the natural background rate of extinction. This chart really puts it into perspective, and it's just shocking. See that tiny little line at the bottom? That's the background rate, the normal, slow pace at which species naturally die out. And that giant spike? Yeah, that's the current rate. It doesn't just dwarf the background rate, it's an explosion unlike anything the planet has seen for millions of years.
So how is this happening? It's not one single thing, it's a combination of all these pressures hitting at once. We're clearing habitats that species need to survive. We're overusing resources that form the base of the food web. Our changing climate is pushing countless species past their breaking point. And we're moving invasive species all over the globe, introducing predators that native wildlife has absolutely no defense against. It's a multi-front assault on the biosphere.
The fossil record shows us time and again that our planet has these powerful, natural ways of wiping the slate clean. Volcanoes, asteroids, climate shifts, they've all ended worlds before. And that brings us to the final critical question we have to ask ourselves. Are we creating the next one?